Okay, so today we're going to be talking a little bit more about the uCharger. This is the battery charging system for the Baby 2 system, 1-cell 3-inch. Essentially, what it is it's a 1-cell XT30 based system, and I'm just tired of having to use converters and then using subpar things from the market, because right now we don't really have a great offering. That being said, first revision I wanted it to be modular, portable, stackable, all those sorts of things. This version, I'm taking a slightly different approach. I haven't had much success with the modular version, so what we're doing here is, this is I wouldn't say it's simple, I just kind of copied it off the data sheet, but this is a switching regulator. It's capable of up to 40 volts input and a 5 amp output. And what this means is, if we have our charging chip, we can actually charge 10 batteries at the same time, which would be very, very great if this does work. The chip that I'm using is a microchip MCP73831. You can see here, this is what one of the modules looks like. A relatively simple circuit, dirt cheap, dirt simple, nothing too fancy here. So essentially what you would do is you have your connector here, this would be an XT30, and battery ground, there you go, charges the battery. So we have 10 of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and these are all connected to this 5 volt output rail, which is capable of outputting 5 amps maximum. So if we are charging each one at half an amp, it could possibly push the limits of the system, but then we'll learn from our mistakes and hopefully redesign it or have less batteries charging at the same time, or maybe get a beefier buck regulator. So let me show you what the PCB looks like so far. So this is what the printed circuit board looks like. So we have a mounting hole here, mounting hole here, mounting hole here, so 4. This is for future if not if I do go ahead and design some sort of 3D printed enclosure for this. I think that would be nice. It would be a nice touch. So you can see that so you got top bottom layers, and if we can turn those things off, you can see here this is the battery input. So this is a power input. You plug in your XT60 here, and it goes to the regulator circuit, and the power is distributed to the rest of the board here. As you can see here, this would be a XT30 profile. So XT30 can be soldered horizontally. XT60, I wish this would be horizontal too. Unfortunately, I wasn't able to figure out a footprint for this. So maybe in the future we can do that to lower the profile of the board. But for now, I know that this footprint will work. And again, this is just a prototype. So we can see here, what I did was, top layer, you have your regulator circuit, and the bottom layer, what I did was I put all the components underneath on the second layer. And I'll get on to why I did that, but essentially it just saves a lot of space. And you can see here, I just decided it would be nice if you wanted to maybe connect up a receiver to test something out, or if you just wanted some sort of 5 volt reference voltage header, well, there you go. And LED, power good. And this one over here, these LEDs are corresponding to the battery that you would plug it in. And refer to the data sheet for the status of the LED. So now, this is what the board would look like. Apologies, fortunately the XT30 connectors aren't fully rendered, but you can see you would plug in your battery here, there's your headers, and if you look on the bottom, this is where the huge weight space, the space-saving implementation has been made, in that this incredibly small chip can actually fit inside of the footprint of this XT30. So then all we needed to do was worry about where do we place these XT30s. And you can see, this is relatively simple, straightforward design, but I just want something that'll charge up my batteries, and I'm willing to, design my own because I don't really see any other offerings out there. And yeah, I know there's been some things to do with parallel charging, and series charging too, where the cells don't necessarily have to be the same. But again, I think that this way is better because this individually charges each cell as if it was in its own battery. So then you really don't have to worry about, charging all my batteries at one time. You can just plug and unplug, do whatever you want, and each 1S cell will get charged individually. So, pretty soon I'll be ordering the prototype for this, soldering it up. Hopefully it'll work, and then we'll see. We'll see where this project goes from there. But for now, I'll be happy if this works and if I didn't completely mess anything up. But alright, that's gonna do it for today, and happy flying.